In the final proposition of Book 1, we're going to prove the converse of Proposition 47, the converse of the Pythagorean theorem, which is, if in a triangle the square on one of the sides be equal to the squares on the remaining two sides of the triangle, the angle contained by the remaining two sides of the triangle is right. For in the triangle ABC, here's our triangle ABC. Let the square on one side BC be equal to the squares on the sides BA and AC. That's going to be the given. The claim is that the angle BAC is a right angle. That's going to be what we're intending to prove. And how are we going to do this? For let AD be drawn from the point A at right angles to the straight line AC, which will do this. We're going to have this point over here, AD, and he says let AD be made equal to BA, which we've done. And we're going to let DC be joined. Just join those two. Now, since DA is equal to AB, DA is equal to AB, the square, which is built upon DA, is also equal to the square on AB. Now he says, let the square on AC be added to each. So let's keep track of this. So we have DA and AB. The squares built on those two are going to be equal. And to those, we're going to add the square built on AC, this other side over here. Therefore, as he says, the squares on DA and AC are equal to the squares on BA and AC. But the square on DC is equal to the squares on DA and AC, for the angle DAC is right. So what is he saying? He's saying that these two together, DA and AC, these are both together DC, the hypotenuse over here. Why is that true? Well, that's the Pythagorean theorem, which we've already proved. And the square on BC is equal to the squares on BA and AC. For this is the hypothesis. That's what's given to us. That AB and AC, the squares on AB and AC, the two legs over here, those are going to be equal to the square built on BC. From this it follows that therefore the square on DC is equal to the square on BC. And from that it follows that the side DC is equal to BC. Those two sides must be equal. And he notes that DA is equal to AB. Remember, that was true by construction. And he reminds us, since DA is equal to AB and AC is a common side, notice we have two triangles which have the side-side-side relation. The two sides DA and AC are equal to the two sides BA and AC, and the base DC is equal to the base BC. Therefore, the angle DAC is equal to the angle BAC. So what we've got here is that the side DA is equal to the side BA, and AC is of course equal to AC, and the base DC is equal to the base BC. Therefore, we have equality between these two triangles, and it follows from this that the angle DAC, which is opposite this side over here, must be equal to this angle BAC. However, that angle DAC was a right angle, therefore this other angle is also right.